Here's a short video animation to show you how restriction enzymes work. So here we have a piece of DNA and a restriction enzyme, which is represented here by the pair of scissors. This restriction enzyme is also known as a restriction endonuclease because it cuts through DNA at or near a specific sequence. So let's take a look at what exactly these restriction enzymes cut. Here's a piece of DNA. The nucleotides on each strand are held together by phosphodiester bonds, and restriction enzymes work by cutting these bonds at specific sites on each strand. Certain kinds of restriction enzymes create blunt ends. These particular enzymes cut at the center of a palindrome. Here's an example of a palindromic sequence that is cleaved by a blunt cutter. As you can see, the restriction enzyme cuts straight through the DNA. Other restriction enzymes produce what are known as sticky or cohesive ends. In these cases, the restriction enzymes cut the palindromic sequence off-center. Enzymes that cut left of center create 5' overhangs, and enzymes that cut right of center create 3' overhangs. In this particular example, the enzyme is cutting left of center, which in turn produces a 5' overhang. When it comes to cloning, it's really important to know whether your restriction enzyme creates blunt ends or sticky ends. For example, here we have two pieces of cut DNA and both of them have a 5' overhang. These two pieces can easily fit together like matching puzzle pieces, and thus they are called compatible ends. Now let's imagine that there is one piece of cut DNA with the 5' overhang and another piece with a 3' overhang. Since the overhangs overlap with one another, they cannot fit together, and thus they are incompatible ends. Let's look at one final example. What if the DNA fragment with the 5' overhang encountered a piece of DNA with no overhang, or in other words, a piece of DNA cut with a blunt cutter? Once again, these two pieces cannot fit together like matching puzzle pieces, and thus they are incompatible ends.